All right, guys, let's get into the content. So the main difference between MAC addresses and IP addresses are that MAC addresses live on layer 2, meaning that they're burned into the actual chipset. IP addresses, on the other hand, live on layer 3, which means that they're part of the network layer. So I've included a couple of different diagrams here, and you can check out where I got them from at the URLs in the URL bar here. But this is just a brief overview of the OSI model, Open Standards Interconnect. At the very bottom layer, you've got your physical layer. Now, this layer 2 here, which is called the data link layer, this actually has two sublayers to it called the logical link control and media access control. We'll get into those in a separate video because it's a slightly more involved topic. But this is the layer 2 here, where MAC addresses live. And MAC addresses, again, are a address that's burned into the chipset of the device, and that could be a network interface card, either wired or wireless. IP addresses live here up on layer 3, which is the network layer. And again, just as a quick rundown of the OSI model, any traffic that you send here from the application layer, like this could be Microsoft Outlook or Google Chrome or something like that, that traffic goes down, and this is an abstract concept, right? It goes down through these different layers down to the physical layer where you actually have your cabling. So, Cat5, Cat6 live here on this layer. And on the return trip, you go back up to the target. They go back up through the OSI stack. So the key thing to know that here, layer 2, this traffic is really only local. There are ways that a MAC address can be sent out across the public internet, but for argument's sake and the sake of this video, just assume that it's not. It requires some special black magic to get it out across the internet. But basically, if you're switching traffic locally within a network, it's going to be part of this layer 2 network here. Any traffic that goes out across the public internet is going to be using layer 3, and that's going to be using IP addresses. So let's take a quick look at this diagram here, just so we can understand how traffic would flow. So if I've got PCA here and this machine wants to talk to PCB, then both of these devices, if they're on a local network, are probably going to be connected to a switch. Now, what happens is PCA is going to try to find PCB by its IP address. All right, so it's going to let's say that PCA here, this machine is, let's say 192.168.1.100, okay? And let's say this machine, PCB, is 192.168.1.101. All right, so PCA is going to target PCB, and it's going to basically say, all right, this is the IP address that I want to target, and it's going to send out what's called an ARP query, which is Address Resolution Protocol. This is a query, it's a broadcast that's sent across the network through the switch, where the PCA is going to ask for the MAC address of this IP, which is PCB, right? So it's going to ask for the MAC address of what it's trying to target, which is 192.168.1.101. Now, if PCB has this, it's going to reply back with the MAC address, and then PCA will know where to send it. Now, at this point, PCA has the MAC address for PCB, so what's going to happen is it's going to send a frame on layer 2 directly to PCB. There's actually no routing involved. So in this case, you see I didn't even connect this router yet. That's because PCA and PCB can communicate with each other without needing a router. Now, let's say that PCA wants to communicate with PCC, right? I'll rename this over here. And I'll give this one an IP address of 192.168.2.100. And I'll give this one an IP address, let's call this PCD, 192.168.2.101. Okay. Now, let's assume that these machines here are also connected to the same network. Now, if PCA here wants to communicate with PCC, the first thing it's going to do is it's going to send out an ARP query for this address, for 192.168.2.100. What's going to happen is PCA is not going to get a response, right? Because PCA is going to ask for this, it's not going to find it. So what happens is PCA is then going to send that traffic out to what's called the default gateway. And the default gateway is, in this case, the router. Now, forgetting the internet portion here for 1 second, right? Because this may not necessarily be here. If this router knows where the remote network is for 192.168.2, then it is going to send traffic to that router. And that router will communicate down here through this switch to this machine. So what's happening here is this router knows that behind this interface, right, behind this connection here is everything 192.168.1 dot everything. And this router knows that behind this interface is 192.168.2 dot everything. So when this PC here, A, says, I'm looking for 192.168.2.100, and it doesn't get a response on the local network from that ARP query, it sends it up to the router here. This router here knows that it's learned about that network over this interface right here, and then it forwards that traffic over to this router, and this router sends it down to the switch, and then here, this PC will eventually get that communication, and then the traffic returns. Uh, well, it just returns. That's actually all it does. That's actually just how routing works. So again, just to recap here, so the MAC addresses here are only used for internal communication. And same thing here, right? If PCC wanted to send traffic to PCD, then you'd be looking at what is the MAC address for PCD. PCC would send out an ARP query for the IP address for PCD. If that works and it gets a response back, then it's going to address directly PCD. And that's basically how MAC addresses and IP addresses work on a high level. Now, as some bonus content for you, the switch maintains something called a CAM table, which is called Content Addressable Memory. This is a Cisco term where basically it learns that out of every port that it's received traffic, it knows that there's a certain device with the MAC address behind it. So as an example, if PCA has, let's say, a wired connection on port number 2 on this switch, and PCB is connected on port number 3, the MAC address of PCA is going to be associated with the port number 2 on this switch, and PCB, this MAC address is going to be associated with port number 3. So what happens is the switch, when it receives traffic from PCA's MAC address and it needs to communicate with PCB's MAC address, then it knows that on this switch in its CAM table that it has PCA on port number 2 and it's got PCB on port number 3. So that's actually how the switching occurs locally. Same thing happens over here on our other example network. And I just want to show you guys a really quick example of what a MAC address looks like. So that's this, right? So a MAC address has two unique parts. It's got the first 3 octets here, which are called the organizationally unique identifier, and on these 3 octets here, excuse me, this is called the device specific ID, or here this is referring to the network interface controller specific. Basically, these first 3 octets here represent the manufacturer's ID, and the last 3 octets here represent the device ID. So a network card can either be wired, like you see here, or it can be wireless, like you see here. Either way, there's going to be a little chipset here. So here you can see that little crab-looking chipset. This chip here is what's responsible for holding the MAC address. And you'll notice that on the wired network controller here, underneath this little plate, there's another chipset here that does basically the same thing. That's where the MAC address is actually burned in. And on an operating system, if you do ipconfig /all, you'll be able to pull up the physical address of that device, and you'll be able to see exactly what that adapter's address is. So you'll see here that this is attached to an Intel Pro gig network connection, and that's the MAC address of this device here. Now, the IP address is different, right? The IP address has been handed out by something called a DHCP server, or it's been configured statically. We'll go into DHCP and static IP configuration separately. But this is the IP address assigned to the device. This can change often, but the MAC address never changes. There are exceptions to this, but high level for the purposes of this video, you can just assume that they won't change. So just jumping back to our diagram here, so this is where the IP address routing will live. It's going to be between these 2 routers. MAC addresses are going to be stored here on the CAM table of this switch, and they're going to be switched locally between these 2 PCs here. Okay, so just one last thing, just so you know, routing occurs in the exact same way as we talked about before with these 2 routers, except if this cloud represents the public internet, then just know that these routers actually connect out to each other, and a lot of them are connected to each other so that there's multiple ways to get from one place to the next, ultimately reaching your destination. And we'll go through that in a later video. But basically what we're talking about here is It's just traffic routing. And there's different routing protocols for this, but a little out of scope for this video, so we'll cover that in a separate video. All right, guys, I hope this video was helpful for you. If you have any questions, leave me a comment below, and I'll see you guys in the next video.